Just going to talk briefly about the difference between even and odd functions. Here are the formal definitions for even and odd. A function f of x is even when the original function f of x is the same as the function when we plug in a negative x for all the x in the domain. Sometimes commonly we'll say this has line symmetry with the y-axis, which means we can draw a line down the y-axis and it cuts the function in half evenly on both sides. The formal definition for an odd function is when f of negative x, what we just did for even up here, is the same as doing the opposite of the original function for all x in the domain. Commonly, sometimes we'll say this has rotational symmetry around the origin, which means I can hold the origin down and I can rotate that function and it lands upon itself. Go through a couple of examples with you. Here's the original function. Let's first check for evenness. So we're going to take this function and we're going to replace x with negative x. I have negative x cubed minus a negative x. And I do a little algebra here. 3 negatives, so that's still negative. 2 negatives here make this a positive. And plugging in negative x does not get me the original function. So this particular function is not even. Now let's check for oddness. So we're going to take what we just did here, and now we're going to compare it to what happens if I take the original function and just change all the signs. I do the opposite of the function. So I get a negative x cubed and a plus x. And now I'm going to compare that to what we just did, and I notice that they're the same. So this is obviously an odd function. So if I would graph this out, I'm going to see that it has rotational symmetry around the origin. Going on to number 2 here, original function, plug in a negative x. So I have a negative x squared plus 1. 2 negatives are going to cancel out, and I get x squared plus 1. These are already the same, so this is an even function. It cannot be both. It has to be one or the other. So if it's odd, it's odd. If it's even, it's even. And sometimes you'll have functions that are neither. So here's the original function. I'm going to plug in negative x, and I get negative x cubed minus 1. So it is not even. The original function and plugging in negative x are not the same. Now I'm going to try changing all the signs in h. So I get negative x cubed plus 1. Doing that and comparing it to plugging in a negative x, they are not the same. So it is not odd, so this is neither. It could be even, it could be odd, or it could be neither. So this doesn't have line symmetry, and it does not have rotational symmetry either. So I'm going to pause and give you some time to work on this one. Determine if f of x is odd, if it's even, or if it's neither. Okay, taking our function and plugging in a negative x. Gotta keep track of my negatives here. I get negative x squared, which makes this x squared, but it had a negative out front to begin with. Those two are already the same. So the original function and plugging in negative x got me the same thing. That's the definition of being even. If you are a visual person, you may have graphed this. It is a quadratic. It has been moved down 8, and it has been flipped over, but you'll notice that that quadratic is still sitting on the y-axis, so that y-axis is going to cut it in half. It has line symmetry, cuts it in half on both sides.